Come in.
You want to see me, Mr. Dlamini?
Ah, Gerald, come in. Sit down. I hear that the school governing body is very pleased with the presentation that you and your committee has made to them about convincing them to invite those two bands to the school concert, and they're very happy with your plans for the food and the transport.
Thanks, sir. Data handling tools have really helped us. We used a pie chart and a bar graph of all our research to show how we came to our decisions. And we showed them how we used mean, median, and mode to set a fair and reasonable cost price for the tickets.
Yeah, well done. But now there's just one slight problem that the governing body has asked me to discuss with you. It seems that whilst the students are supporting you in buying the concert tickets, they've forgotten to collect the cans for the recycling project. And we were wondering if you could come up with some ideas to help us with the project.
What if we join the two projects? I mean, what if we made a poster that said something like, the learner in each class who collects the most cans for the can recycling gets a 10 Rand discount off the concert ticket and a free hamburger?
I like it. That's a very good idea. I'll put the suggestion to the principal.
Glad we could be of assistance.
But that's not all. The principal wants you to display data of how many classes are bringing lots of cans to school and how many classes are letting the school down by not bringing any cans to school. And we're hoping that will encourage some of those classes that are not pulling up their weight.
That sounds fine. We can get the data we need from the teachers in the classrooms.
Yes, you can, but be very careful in the way that you display the information. We don't want the whole school to know which class is doing so badly, or they might just give up straight away. And we don't want the classes that are winning to know as yet, because they will just stop collecting.
I understand.
Hi, my name is Eloise. Welcome to another lesson in our series on data handling. By the end of this lesson, you should be able to group data on a frequency table and represent it on a graph. So Gerard, did you find out how many cans each class has collected already?
Yes, we went to the teachers and asked them for their data, but we didn't know what to do with it. It's just too much. Here's our list.
Okay, let's start by thinking about what it is you want to show with this data.
Well, we want to show the principal that some classes haven't collected that many tins and they really need to start collecting. And we want to show him that other classes have collected over 100 tins. So if we can put all our information on a graph, maybe that will motivate the other classes.
Good idea. It gives them a picture of how they're all doing and what they need to aim for. So what do you need to show on the graph? Do you want each class listed along the x-axis?
Well, we thought about that, and there's 25 classes. So if we put a bar on for each class, that would be 25 bars, and that would be difficult to read.
Okay, so you want to show how many cans each class has brought without labeling the classes. It sounds like you need a frequency table. You want to know how many classes collected how many cans.
We tried to do that. We wrote down all the numbers of cans, possibly from 0 to 200. Then we started putting tally marks for each class. Here's 8A with 84 cans, and here's 8B with 195 cans. But we realized we don't want to end up with so many separate bars plotted on the graph, and a lot of the numbers will end up with a 0 next to them.
It's good you realized this early on. You could have made a lot of unnecessary work for yourselves. Organizing data is supposed to make things easier to read. To make the numbers easier to use, we could make each row in your frequency table a group of numbers rather than just one number. Depending on the size of your data, you can arrange it in groups of 5, 10, 20, 50, 100, or even 1,000. We call these groups of numbers class intervals, and the table is called a grouped frequency table. Let me show you what I mean. Your data goes from 8 to 195, so your class intervals should probably start at 0 and go to 200.
Right. We've decided for now, we're only going to use our graph to show the cans already collected. Then we won't have to go past 200. And we've also decided to make a new graph each week. That way we can monitor our progress. And then maybe we can exceed 200.
What size intervals do you think we should make?
Would groups of 5 work?
That means your table would go up in 5s. So you would need, let's see, 200 divided by 5. You would need 40 class intervals. That's still too many to show on a graph, Gerard.
Oh, I get it. Even if we used groups of 10, we'd still have 20 class intervals, which is still too many. How about groups of 50?
50 in a class interval means you will only have 4 class intervals, and you'll find it very difficult to see which classes are ahead of the others because they will all be in the same 4 intervals.
So how about we use class intervals of 20? That would mean we have 10 groups, and that will be so much easier to work with.
I agree. So we'll make your class intervals go up in 20s. Now you're ready to make a frequency table.
Right. My table has 3 columns. 1 for the number of cans, 1 for my tally, and a 3rd for my frequency.
Hang on a minute, Gerard. How many cans did class 9C bring?
40.
Exactly. So where will you make your tally mark for 40?
I see what you mean. There are 2 places I could put it. It could go in the 20 to 40 group or in the 40 to 60 group. Couldn't we just write in both?
If you did that, it would mean 2 classes brought 40 cans, where in fact only 9C did. You need to rethink your class intervals so that there are no overlaps. And you should check how many numbers there are from 20 to 40.
20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. That's 21 numbers. So if I wanted 20, I'd have to start 20 to 39. So the class interval should be from 0 to 19, 20 to 39, 40 to 59, and so on, until we get to the last one, which will be 180 to 199.
That's great, because there are no classes that brought 200 cans, so it's fine to stop at 199.
8B collected 195 cans. That's over there. 8D has 62. There we go. Now I just have to add up my tally marks. 6 classes brought between 0 and 19 cans. 5 brought between 20 and 39. And another 5 brought between 40 and 59. 3 brought between 60 and 79. 2 brought between 80 and 99. And 1 brought between 100 and 119. Another one brought between 120 and 139. And so did 1 between 140 and 159. None of them brought between 160 and 179. And 1 brought between 180 and 199. I just want to check if I haven't left any classes out. There are 25 classes in our school, so let's see what the total adds up to. 6 plus 5 plus 1 plus 1 plus 0 plus 1 equals 25. So my tally is right.
Great! Now you're ready to put this all onto a graph. Then you can make a big poster so the principal can explain all of this to the students. I'm going to suggest that you put your class intervals on the vertical axis. Then you'll end up with bars across your page instead of up and down the page. I think this will make the graph a little more interesting for the learners.
Okay, so the y-axis will have the class intervals on it like this.
That's it. Now don't forget to label that axis. It will be the number of cans.
Oh, but what do we put on the other axis?
That will be for the number of school classes, the totals from your frequency table.
Oh, okay. So the highest number in the frequency was 6. So I think I'll label it from 1 to 7.
Good. Now you can mark off a bar for each class interval.
Sure. It will be 6 here, then 5, 5, then 3, 2, 1, 1, and 1. Nothing in this interval, and then 1 in the last interval. And here it is, the final graph.
That's great, Gerard. You can clearly see how many classes haven't collected enough cans. All these classes have brought less than 100.
It's also clear that this class is way ahead of the others. So the principal needs to encourage the other classes to catch up. If we carry on recording the cans as they come in, then we'll have to make a new graph each time. That's easy enough. We just need to make space on the y-axis above 200.
You've done very well today, Gerard. The grouped frequency table and your bar graph provide some interesting information for the principal, Mr. Dlamini, and the school. I'm sure they'll appreciate it, and I hope it helps them bring in more cans. Now let's recap on what we've learned about group data in this lesson. Gerard had too many numbers for a normal frequency table, so he grouped the numbers in class intervals. All the class intervals had to be the same size and not overlap. Then he made a tally mark for each number of cans collected. He checked that his tallies were right by adding up the total of the numbers in the frequency column. Then he used the totals in the frequency column to draw a bar graph of the data. Well, Gerard, that's about all the help I can give you at this point. All I can say is good luck with the concert, and I hope it's the success it deserves to be.
Thanks, Eloise. And I speak for Sigra, Cindy, and of course for myself when I say thank you. Because data handling has helped us make some good decisions when it came to the planning stage.
You three worked hard to get to this point. Now it is your turn to do some data handling. In this series, we have taken you through all the stages of data handling: research questions, collecting and organizing data, representing the data on graphs, and interpreting your data. We've also shown you how to use the different kinds of averages of the data and how to group data. Work in a group and identify an issue from your community where data handling could help you make good decisions. Set up your own research question and use the steps of data handling to help you come to your conclusions. Remember that you'll need to collect and organize your data, represent it on graphs, and interpret your findings. Well, that's it for today. We hope you've enjoyed learning about data handling with us. Till next time, goodbye.